All right, we'll let people join as they come into the meeting, but we have a lot to cover today, so we definitely want to get started. I'm very excited to listen in to Keith Skidmore and Kim Bishop share with us a lot of their knowledge, experience, and recommendations for different types of lifting applications and products that Interface provides to help solve some of those engineering challenges. For our agenda today, and as a reminder, this event is recorded, so we will be sending a recorded link to everyone. If you have questions about any of the topics that we're going to cover in this agenda as we're going along, please use the chat feature. We'll try to get to those at the end of the event when we do our frequently asked questions. So here's what we've got to cover today. We're going to talk about the rise in new lifting solutions, 5 whys of using the load cells for lifting, some of the sensor-based lifting products that are available, instrumentation and different types of solutions for gathering data, a range of systems that are actually designed for lifting use cases. We'll go over some really key technical considerations and challenges from an engineering perspective, as well as detail a few lifting applications. It's quite diverse across different industries. And then share some best practices and tips. And then, as always, with every interface event, we'll end that with some FAQs. So before we turn it over here, again, thank you for attending this event, and we look forward to sharing with you some great information about lifting applications. Keith, Ken?
Well, all right, so we'll start off with the rise in new lifting solutions. Let's start off with a fun topic, a little bit of the history of lifting. The earliest known lifting equipment was the Shadoof. You can see it on the right. A lot of pretty interesting principles in that. We've got some fulcrums and, some cables and things like that are ropes that are used. A lot of similarities in today's lifting applications. And what they did is they used this to lift water from the underground. The ancient Egyptians and Mesopotamians also used pulleys to lift heavy objects. Ancient Greeks and Romans developed more advanced lifting equipment, which included cranes and winches. In the 19th century, the steam engine was used to power lifting equipment, making it possible to lift even heavier objects. And in the 20th century, electric motors were used to power lifting equipment, making it even more efficient. So same types of lifting cases used today. You can see we have cranes and forklifts, hoists and winches. And what's changed in lifting is the modern technology that's used. Everything from engineering designs, different materials, sensors used to operate and maintain this type of equipment has kind of changed the concept of lifting today. Lifting equipment that uses load cells or force transducers commonly are cranes, lifting gantry systems and mobile gantry systems, jib cranes, engine floor cranes, scaffold runway systems, engine hoisting, rigging equipment, pallet movers, elevators, loaders, and bulldozers, and it goes on and on. Different types of sensors are used in each one, depending on which one fits the best or the best match to the environments. Along with that, changing requirements is advancements with lifting equipment. So you'll see throughout this presentation, we're going to present some sensors that use wireless components. You can even transmit your lifting measurements to the cloud and get that, share it with others, record it up there. And environmental exposures, of course, lifting doesn't occur just indoors, but outdoors as well. So that equipment, these load cell sensors have to withstand the environment. Depending on the lifting application, the size of device will change. So it can be small, it can be large. and you have to have sensors that can adapt to that. Some lifting applications require precision measurement. Some are involved in, automation. There's continuous monitoring that's done, and people want to record that, and safety alarms and systems based on key measurements. So we're going to show you a lot of that with different application things as we go through this presentation. Next slide.
All right, this is Keith. 5 whys for using load cells in lifting. So number 1, and it's here for a reason as number 1, is safety. Load cells can help prevent accidents by providing real-time feedback on the weight of the lifted load. Imagine if load shifts or something topples over, somebody gets hurt, that's a real disaster. And so monitoring load points as items are lifted or moved can prevent serious injury or even death. Why number 2? Quality control. Load cells can improve quality control by ensuring products are lifted to the correct specifications to help prevent damage and ensure that products meet customer requirements. And if you're lifting an item, it could get damaged. Say it's hung up and you don't know it. The damage may not be evident. The product is just compromised. It could even ship to a customer and then fail in the field. So by monitoring lift points as a product or system is moved, you can ensure that it's being lifted and moved according to specified parameters. No damage is incurred, and the system can ship without compromise. Why number 3? Compliance and overload protection. In fact, there are certain regulations, certain industries, certain regulations govern things such as lifting that it's actually against the law to say move something without monitoring while that's being moved or lifted. So if something's lifted overhead and there may be people beneath it, definitely regulations about how that can be done and how it has to be monitored and proved to be safe. OSHA has a lot to say about safety in the workplace. Why number 4? Equipment monitoring for efficiency. Load cells, load pins, load shackles, tension links can be used to help improve efficiency by automating the lifting process. For example, if something's going to be moved through a certain motion, that speed and movement can be monitored to make sure it's done safely. If there's jerking or things getting hung up, it's important to know that. That may damage equipment, may slow things down, may cause downtime. So monitoring while moving is important to create an efficient or to maintain an efficient production environment. Why number 5? Cost savings and maintenance. Again, if equipment is used within its, say, intended parameters of use, it will last longer. So if you have equipment that's, say, being overloaded every time you use it, it may be wearing it out more quickly. It might be that you need to do that, but you still want to monitor and know that that's happening so you can, say, schedule preventive maintenance as opposed to having, downtime unexpectedly. So 5 whys. On to Ken.
There we go. We'll start with the low profile load cells. So a lot of you have seen this used in many, many different applications, but it's perfectly suited for lifting as well, because with the installed base, you basically have a threaded hole in the top, a threaded hole in the bottom, and you can connect rod and bearings to it. So the load strength that you would have when you're doing lift. Why a low profile load cell would be great is is an advantage is when you have sub 0.1% measurements that need to be made. Some types of lifting require super precise control, we'll call it. And so, maybe it would cause damage to equipment if it wasn't lifted properly. So these are the perfect products to use with it. Next slide. Well, the next slide has our product 1100 on it. And so similar size and shape as this particular product, but has more precision to it. So as the 1200 series product had below 0.1 to 0.04% performance, the 1100 has 0.025%. And again, connects up in the same manner as all the rest of the products that we showed you previously. You can use clevises on these, and like I say, definitely put them in your load string just the same as the 1200. One thing I did want to mention about the 1000 series load cells is that they have a higher overload. So in case more safety margin is needed, our 1000 series in the same package would apply. All right, let's move to the next product, which is beam type load cells. So beam type load cells, include products like shear beams and mini beam load cells. And so what happens with these is that they're integrated into products. A shear beam load cell can fit into the forks of a forklift, for instance, or into the forks of a pallet jack. And so because of that, easy lifting can take place using this, let's say the pallet jack, and you can instantly get a measurement onto a display. You'll see those readily available, at places like Uline or Amazon. Those kind of people sell those kind of units. Other types of lifting that can take place, maybe a smaller capacity, where some of our lower capacity mini beams can be integrated into it, and give good measurements, and yet we can have internal overload protection in case of shock or any other kind of measurement issue. Loading shock that's introduced into the application where the load cell will not get damaged. Next product is the load pins. So a little bit more detail on the load pins. We basically have two main types, and one is a wireless pin, and the other one is a wired pin. And so, they're designed product that is made to be used in the outdoors, and they're usually customized. And so what we do is we look for places in the structure that has a pin, and we can customize a pin to fit into that location. So they're usually easier to implement into an existing application. And in the case of the wired option, maybe it would be a shorter distance where a wire could run to a particular instrument. We have many of them that Keith will talk about soon. Or in a wireless situation, we can connect it up and connect to a wireless handheld display, and you can monitor it on a handheld or even on a PC. Capacities on these go all the way up to 3 million pounds. And again, since they're customizable, you can fit them into pretty much any application and any environment. The next product we're going to talk about is our tension link load cells. So tension link load cells basically have two holes in the ends so that you can connect straps to them. And they come in the wireless version and wired version as well. There are some models that are made from strong aluminum, so they're lightweight, and others are made from Others are made from steel. So in that case, depending on your application, in some cases, there may be movement. You might choose the aluminum versus the steel version. Same advantages apply where wired, you would probably use that in a application that may be closer to the instrumentation. Wireless, you can go up to about 600 meters away and then transmit that to a handheld or to the PC computer. And of course, when you're doing that, you can log data onto our Log 100 software. So you can see we've got a pretty long battery life as well. Next slide. So we have a bunch of wireless load shackle offerings, again, very popular in the lifting industry. We have different shapes, as you can tell. So one of them looks more like a D, and then the other one looks like a B. And so that's why they're called either a B bow type shackle or D type shackle. They come in wireless and wired versions. What's pretty neat about these is, the shackle itself can't really be customized. We use a brand called Crosby. It's very reliable. So you can count on it in your application, and then we customize the pin to meet your needs. But we can also do some customizing, like putting some cable protection if your application may have a way of possibly hitting the cable and shearing it. We could put a special protective cover on it based on your particular application. One thing that's pretty interesting about this picture, if you take a look at it, the blue module that you see on the side of some of these is our wireless module. And in some of these, you can see it looks quite small. And yet it's the same size. So it's about 3-inch diameter. But as the shackles grow, it becomes smaller and smaller. So, we can sell these in over 2 million pound capacity. And we have to key customers that are lifting very heavy objects. The thing you see in the middle of this is what they call a centralizing bobbin. And what that does, if you have a cable, is it keeps the cable in the middle of the load pin section of it. And so that allows for the proper measurements to be taken, because load pins need to be loaded in a specific way. And when they are, you get very, very good measurements with them. So little options like this kind of help you in your application. Again, the same wireless handheld displays will work with the shackles if you're using a wireless, or our instrumentation that we use for wired will work with this as well. Next slide. So we have flame-proof load shackles, and the reason we're showing this off, is because, our partner LCM is really strong at ATEX certifications, and so there's a lot of lifting that goes on in hazardous areas. And so a product like this is designed to make sure that if any spark is generated, it stays inside of the enclosure on the side of the load shackle here. And so it won't ignite anything outside of it. And but we can do any kind of load pin or load shackle in an ATEX version for your application. And so don't be afraid of using the proper equipment in those areas. We can get you the right kind of protection you need to be safe. Next slide.
All right, instrumentation used in lifting. Load cells and shackles, tension links, all those things output a signal, but the signal needs to be read or displayed by another device, which would be an instrument. So we have different types: indicators, signal conditioners, meters, displays, also data acquisition, logging, and graphing. Can display multiple load points simultaneously. We have portable displays, which could be handheld or battery powered, could be moved around. junction boxes, which take signals from multiple sensors and sum them together. Those can be either analog or digital devices. Data acquisition systems are actually logging data, potentially graphing or even doing complex analysis. And then again, wireless and specialty devices that are specifically designed for a certain application. Here are some examples. Indicators have a display on them. They can be self-contained, can have lots of fancy functions for controlling, relays and things. You can have alarm points. They can have special programming, say, to monitor the angle of a crane boom so that the, maximum capacity may vary with the boom angle. They could be calculated and alarmed or displayed. Signal conditioners take the sensor signal and convert it to something else like 4 to 20 milliamps or a digital Ethernet, EtherCAT, Profinet, whatever, to attach to, say, an existing network. Panel meters are displays, but they are not intended to stand alone. They can be mounted, say, inside a box or a panel. So say somebody had their own electrical panel, wanted to mount a display into it, the panel meter would work well. Panel meters display, they also may have alarm or digital functions and can be used to control other devices. And then, of course, that acquisition ranges from PLCs to standalone units that can log or control or take signals from multiple devices and log everything synchronously. So here are a few examples of portable displays. We have our 9330 and our 9325. They're somewhat different. The 9330 is quite fast and has an SD card for logging internally. It also has software that comes with it that can allow display and logging of data. And then the 9325 is, again, a battery-powered handheld display that features TEDs. And TEDs is very useful. It would be useful if you had, say, multiple load cells, but you only had one display and you wanted to walk around and plug your display into each load cell and take a reading. What TEDs does is it allows the instrument to self-scale the load cell via data that's stored on the chip that's part of the load cell. And so the instrument can be turned on and take a reading, then you could disconnect it, walk over to the next device, plug it in, turn on, and take another reading. I talk about sample rate. These are both relatively fast. Why do you care for lifting or weighing? A lot of times you don't need something very fast, but if there's any kind of shock loading, and say you have safety ratings on the equipment, a shock load is as bad for the equipment as a static load. And if your sampling is too slow, you may miss a shock load. Say a load drops and bounces on the sling, for example, you could get quite a bit higher load. Or if you say you're moving quickly, pick up something, the acceleration of that load can create much higher loads than, say, the average load. So might be important to see that. Next slide. Junction boxes. A lot of times you might have multiple points. You had like 4 points underneath the crane. Example, you had load cells, so you're measuring the total weight of the crane and the items being lifted by that crane. You may want to sum those together and just get a single load. Junction box can do that. And then something like a digital junction box goes a step further and actually measures each signal independently and adds them together digitally afterwards. Those are useful, say, for troubleshooting. You can actually see what each load cell is doing. So if there's a problem, isolate it more quickly than with an analog junction box. You also may be able to query it and get the individual load readings into a PLC or some remote device. Next slide. Data acquisition systems. Again, say you're monitoring, you may want to actually log and maybe say have multiple devices, maybe a position sensor, accelerometer, a load cell. Might want to monitor all of those things and have them say synchronous and have them logged, say, on the same plot. Say there's some motion being controlled, lifting and moving in an article, maybe a certain parameters that entire motion must stay within. You might want to log and monitor that and then do some analysis afterwards. Say every day you go back and look and see if the equipment is functioning, say, within certain parameters. All that can be done by logging data and analyzing it afterwards. Next slide, please. We have displays, as we talked about. Many of them with lifting want to be wireless because wireless is really nice when you have say things that are moving, you don't necessarily want a cable attached to a crane hook, for example. So wireless is nice. Once it's wireless, that data can be displayed or logged to any number of different devices. For example, you could have a handheld that you're monitoring loads. You could actually have a panel meter in a panel that's also displaying that load. And then maybe you've got a big, large display up on the wall so everybody can see the load. All of that can be done with a single transmitter being read by multiple devices. Also wirelessly, you could be logging to a PC for collecting data and analyzing it afterwards.
Okay, we're going to talk about portable system. So this is pretty neat stuff. It's fun. Interface get very good at putting these kind of things together. What you see here is a portable system. It's the yellow case is called a Pelican case. And we put together a custom foam cutout that matches up, in this case, to a panel box that includes 5 different displays. This could power up to 5 instruments for about 24 hours. It's rechargeable. We've done systems that can be recharged by 18 volt, 220 volt, 110 volt. So some, let's say helicopters, things like that require different voltages. So this thing could travel along with you. Custom programming is available for specific instruments. So if you're doing some kind of a project that requires batching or things like that, we have instruments that can, we can put a recipe into, and they can do this kind of work and be powered with a battery and be portable. So all types of applications, especially lifting, can be considered with this kind of system. Keith, to you.
All right, this is an example of a wireless system. The items that the customer was lifting had 2 load points. These shackles are attached at each point, and you can have a display showing the loads at each point. And so they should be even and should both increase in sync with each other. So the operator can monitor that, and if there's an issue, they can you hit the stop button and assess, right? Maybe the load is shifted. You can go and configure things. So this was a couple panel meters mounted in a box. The box is mounted on the wall, has a power switch on the side, has a couple puck antennas on the side for receiving the wireless data. And those antennas are attached to the back of these panel meters, and the panel meters are displaying real-time load.
Okay, this is a Bluetooth-enabled system. Now, Bluetooth doesn't log, but it's quite handy if you've got your phone and you've got, in this case, a load shackle or this attention link. But of course, we can do this with load shackles, even our low-profile load cells, and you can log it straight to your phone. Saves you the cost of a handheld display. We have it available on both and the Rangers, long battery life. And we can, put on a cabled unit or have it integrated like you're seeing in this picture.
This is an example of a system we're actually building in-house today. It's for a customer who had a problem where they have a hoist and an operator operating the hoist and lifting a relatively valuable item and positioning it into place. And if the operator isn't paying very close attention, they can damage something. And in fact, they did damage to the tune of about $50,000. And so immediately they began looking at a way to kind of automate this process, automate it as in you can take out the operator's attention. If they're not paying attention, you would still have some safety measures to make sure something doesn't get damaged. So what they have here is a wireless tension link transmitting to a box that has an antenna and a display mounted in it. The display has multiple settings that can be set via this key switch. And so say setting 1 or setting 2, the key comes out. And so somebody like a manager or supervisor can go in and set the key switch to position 1, and that's item 1. And then he takes the key away, so now the operator can't change that. And then that alarm module on the top of the box turns red if a certain threshold is exceeded, and then actually has an audible alarm if a higher threshold is exceeded. And so when they're lifting this device or object, you know, if it starts to hang up or whatever, they'll know it. And again, the operator may not be paying attention. This will get his attention, the light, and then of course the audible alarm will notify. And then again, when they change articles in production, the manager comes over and switches the switch, and then again walks away with the key so that it's always set up properly for that operation. Next slide. Technical considerations and challenges. So when lifting something or rigging something, it's important to think about not only the load, you know, as it stands, but what are you going to do with it? Maybe it has to be flipped or moved. I mean, you're picking something up, then you have to flip it in space so that it can, say, fit through a doorway or some opening. Maybe you're loading something into a calibration machine like we do here. We have to turn something on its side to slip between some posts or something. So it's important to consider that. And you certainly don't want to think of that as an afterthought. We have something up in the air and people standing around, and now you're wondering how it's going to move safely. Is there special rigging arrangements required? The manufacturer may specify lift points and certain methods. You know, those need to be followed. So it's important to understand, you know, if something may have a required or a suggested arrangement for moving it, needs to be noted. Again, our lifting points provided. If something is intended to be lifting or lifted, it should have lift points not only provided, but, you know, visibly marked or in the documentation. These are lift points. You know, certain points, if you try to pick something up by those points, they'll ruin the item. You imagine, you know, car, if you flipped it upside down and tried to pick it up by certain points of the suspension, you know, or whatever, you may ruin it. So there'd be lift points and points that are not to be used. Say what loads are involved and how accurately are the weights known. Sometimes an article to be lifted, it's very well understood exactly how much it weighs, where the center of gravity is, where the lift points are. Other times you might get something that nobody knows how much it weighs or maybe where the center of gravity is. So that's important. If you pick something up and the CG is not only not where you think it is, or maybe it shifts during movement, that can cause real problems, safety and damage. So what gear is available? Is it rated adequately? Again, lifting devices may have to be certified. You know, slings and things are rated for certain loads. Have they been tested, been bought from a reliable source, and you know that they are going to meet their ratings? Needs to be considered. You don't want to find that as an afterthought that you don't have the right gear for lifting something. Again, is the equipment strong enough to lift in the recommended arrangement? In certain cranes and things are rated for certain loads. Those may have some gotchas, though, maybe not be, you know, rated for the same load if it's a fully extended or something. So you need to understand the equipment being used. Again, spreader bars and things may be required, and those would be just, say, to spread the load appropriately on a sling so that you're not, say, overly loading a single point. Again, headroom restrictions. We have a number of customers who they have to move things around, and you really don't have room to get a crane in. So you're moving a large load frame into a lab, for example. There may not be room to come in with a crane, so might have to rig something. Sometimes you even have to modify the roof or the ceiling, come in with a crane through the ceiling. So things like that are worth considering. Next slide. So when something is being moved, it may or may not be stable, and it may not be immediately obvious whether it will be stable or not. But you can imagine in this situation, say you've got an item that's say on a pallet and it's being lifted. If that item were to shift, you know, the CG may move. It may cause it to tilt. That will cause the CG to move even further as the item slips further, and boom, catastrophically, the whole system say flips over and you drop the load. Very dangerous. So say to mitigate that, you might monitor the load points at each corner. And now if the load starts to shift, you know it, and stop, you know, assess, reconfigure. Next slide. This shows a tank. You imagine this tank might have water in it, might have some kind of sludge or slurry, might even have a buildup on one side of the tank or the other. So it could be assumed that the CG is right in the middle. That may or may not be the case. or it may start in the middle and may move to one side or the other as the tank tilts a little bit. And as soon as it moves, that may cause it to tilt further. And again, may end up with this tank with one end pointing down at the ground. And if somebody's below it or equipment is nearby, you could see that something could get damaged or someone could be hurt. So again, monitoring not only the total weight, but maybe load points at the connections would tell you if things are shifting. And again, you could then make a decision whether to move forward or to stop and reconfigure. Next slide. So this shows a little bit about rigging. If you have an item that has a center of gravity, and here we show that it's being attached to at points that are below the center of gravity, depending where that hook is up above, you can either have an unstable or a stable load. And basically, if the hook is below where the center of gravity is, or the shackle, it will be unstable. And it may not be obvious because it may not be super obvious where the center of gravity is. So you can see by extending those lines, those slings on the lift points so that the shackle is quite a bit higher than the item being lifted, you can ensure that the CG is below that. And here we show some angles. Basically, the idea is that angle A has to be smaller than angle B to have a stable load. Next slide. So this shows kind of a similar item being lifted, but using a spreader bar. The same thing applies, though. On the left, we'd have a stable configuration. On the right, it would be unstable. A little bit beyond the scope of this webinar to talk about stable and unstable rigging, but just to note, it's extremely important. Imagine whenever there's an unstable loading condition, things can shift. And as soon as they shift, get very violent consequences. So imagine if this thing were to tip over and drop something, and now the load completely unbalanced and maybe goes, swinging across the room or something, you damage equipment and injure people. So extremely important. Again, load monitoring is something that's really important. Might monitor at all of the attachment points to make sure that the loads are exactly as intended during the entire lift. Next slide. Troubleshooting, the system isn't working well. It's not always obvious with lifting. Sometimes it's relatively easy, though, to pick up something that's relatively known weight and see if it's measuring correctly. So the lifting, again, that's maybe easy enough to do. You may not have anything you can lift, though, that you know what it weighs. But again, in troubleshooting, you have, say, wireless systems. You have line of sight issues. Wireless likes to work line of sight. It will bounce around, but you may or may not get signal with wireless. We do have systems, though, that are able to be used for site surveys. We have repeaters and things. So typically a wireless system can be made to work, but it may be important to do some surveying to make sure that you're getting strong enough signal at all the areas that want to listen to the signal. Installation, mechanical installation, very important. They can be binding. You want to make sure that the load is load axis is through the load axis of the load cell. And sometimes if you have a load cell mounted, say on a I-beam, and you have a sling coming off it at some angle, the load isn't really pulling through the center of the load cell. So maybe it needs to have a rod end and a clevis, for example, so that the load cell can articulate and align. So again, if you're not getting good readings, it may be mechanical. You look at all of the items in the load string. Environmental, certain load cells are more suited for cold or wet environments. So if you have, say, premature failure, it could be that the load cell or the lifting device measurement system wasn't, say, rated for the environment. Connectivity, load cells output signals. Those signals have to be converted or read, by something else. And so if something's not working, may or may not be the load cell or the lifting device. It could be the cabling, could be the wiring, that the cable may not be wired to the reading device correctly. Could be, the actual reading device isn't calibrated or scaled or could be damaged. So it's important to kind of consider the entirety of the system and then, try to isolate which device may or may not be the issue. Again, signals and outputs, maybe some incompatibilities. If it's 4 to 20 and it's scaled so that you get 4 to 20 in tension, but the load cell is only being used in compression or vice versa, you can have issues. So important, again, to look at the signals and are they compatible with the devices. that are reading them. Cable lengths can be an issue. You have long cable runs and say they're out in the sun, the temperature changes, the signal basically changes due to temperature, and you can get drifting, and you think it's problems with the device, but it's really temperature sensitivity. And so that can be mitigated by, say, running the cables in, troughs, or insulating them somewhat, or maybe using wireless, or changing the position of the equipment so you don't have as long a cable run. So I guess the bottom line is, when you're troubleshooting, you need to consider the entirety of the system and try to isolate which item may or may not be the culprit. Moving on.
All right, let's talk about some lifting applications. The first one we're showing is a crane capacity verification. So the customer's done some advanced planning. Of course, they installed their crane, and then they purchased our WTS TL wireless tension link. And of course, we have the lightweight one or the one that's made of stainless steel. Either one will work fine. And then along with it, they purchased a relay module. So we call it our WTS RM1. That's going to provide them with relay outputs based on the readings that come from the tension link load cell, and set some alarms off, either a light bar maybe, or a horn. They also have a base station, a handheld base station, so they can monitor the load as it's lifted. And also what we call a BS4, which is a USB base station that comes with the supplied Log 100 software. So as they perform this verification process, they'll be able to log to the PC all that occurred during the test. So the picture is showing them lifting their test load, which is at the capacity they want to test the crane. They lift it, and as they lift it, of course, it puts a tug onto the tension link, and then the load that the tension link sees is wirelessly transmitted to all three of the devices, the handheld, to the BS4 USB base station, which goes to the PC, and the relay module. If load is exceeded, a safe load is exceeded, the relay module will click a relay and activate one of the alarms that's set. At the same time, the BS4 is recording the measurement that the tension link recorded into the Log 100 software, and the operator can also be reading a handheld display, seeing what weights are actually being applied to this crane. So very nice, complete system that we can supply, and the customer had success in crane capacity verification. Next slide.
So this is a neat one. Customer who's developing kind of drone package delivery systems, and what they did was they installed a load cell in each of 4 legs that attach to the gripper that holds on to the package. And why this is important, just like with rigging, if this load is, say, unbalanced, it'll affect the flight controls on the drone. If it's, the load is shifting, it could cause erratic behavior. So they want to study that and, tune their control systems to react appropriately. They also may want to build these into every drone so they can use this in real time as part of the flight control system. Also, say this drone were to try to pick up a package that was too heavy, say it's supposed to be cotton balls, but it really was a load full of ball bearings. They should know that, not try to just fly away with it. Also, you can calculate things like expected flight time. If you're picking up a lot of heavy packages, it's going to need recharged earlier. So lots of things that can be studied and understood by monitoring load points during operation.
Okay, this is a spacewalk simulator. So basically, you've got a structure like this installed inside of a test cell that can basically simulate a spacewalk environment. So you would expect that, you would need a good load cell. In this case, we've got our welded stainless steel S-beam, and that's hooked in line with the structure that you see there. It's kind of a gantry looking system. And then it's connected to our DMA2 signal conditioner. So as this spacewalk simulation takes place, the forces that are seen as the spacewalk takes place with the person in line, they can record the measurements to their control system, and then of course make adjustments to whether it's the spacesuit or the movements, whatever they're trying to study while they're simulating a spacewalk. Next slide.
So this is an example of a gantry crane. Some cranes may have load monitoring built in, many of them do not. The customer had a crane that did not have that ability, but it's important for them to know how much the packages, the articles that they were receiving and moving around weighed. One is just to make sure they're not overloading the crane for safety related reasons. And so this particular crane had load pins, or I should say, they didn't have load pins, they had pin joints that could be replaced with load pins. These are custom designed pins. Everyone's custom, so don't be scared off by the word custom. We can basically make a pin that'll replace a pin, but adds measurement to the pin, and then that measurement can be used to weigh or monitor a load. So in this case, there's a wireless load pin, wirelessly transmitting to a handheld display and also to a PC, so they can log and monitor remotely, and then maybe go back and review, monthly, see what kind of usage this crane had seen, and they can schedule their preventive maintenance accordingly. So a lot of interesting data that can be used to improve your business.
Okay, this is a bridge lifting and positioning application. And so what you're doing here is putting the pieces of the bridge together with, coordinated efforts with two different cranes. So in this application, the customer is using wireless load pins on both cranes, and then they can monitor and log them using the WTS BS4 USB base station into the PC. And also they can see what actions or loads are being placed on either pin with the WTS BS handheld. So again, the load pins were custom fitted to match the crane's size and strength and loads being lifted. They're right IP level, so more than likely an IP67 protection. The wireless load pin can transmit up to 600 meters. So depending on where the recordings want to be taking place, where power exists, the power of the PC, as long as it's within the 600 meters. Although if they wanted to go further, as Keith mentioned, we could put an active repeater in the middle to double that distance. And then, of course, they just monitor this for safety and make sure that they're lifting it simultaneously and they don't have any unbalanced loads, and put this together in the safest manner possible. Next slide.
This is an example of a patient lifting device. It was not originally set up to monitor weight. The customer wanted to add that. This is a low profile load cell that was installed, say at the top. You can see that circled. The reason low profile was used is the way that's designed. The idea is to kind of control the load, so you don't want it just pivoting and hang there like the nest cell or something. So it wanted to be rigidly mounted so those arms maintain their positioning. Low profile load cells are good at situations where there are bending loads, so you can ignore those basically. We did have to oversize the load cell so that it wouldn't be damaged by the bending, but it's able to withstand this. They could bolt this in. Again, something like this could be moving around. You don't necessarily want wires going to it. So it's wirelessly transmitting to a PC-based logging system. Something like this, they could be moving patients, say, on a daily basis, and they can monitor the weight from day to day to make sure they, say, aren't, becoming malnourished or whatever. Some of these are also used for measuring, say, like body fat, where you can lower somebody into a pool of water and see how much their weight changes, depending on whether they're submerged or not. So, pretty interesting application.
All right, let's talk about some best practices and tips. Tip number 1, select the right force sensor. So as you can see, there are many different types that can be used for these types of lifting applications. And it's important to kind of take into account, what force is going to be measured, what kind of accuracy is needed, the dimensions, what's the environmental conditions. And so, proper planning ahead of time really can help you so that you don't have trouble, when you're in the middle of trying to use the sensor. Tip number 2, proper installation will define your application success. This is so true, especially when using, products like load pins. Load pins appear to be, pretty simple, and they are, but there's a real technique if you use the manuals that we have on our website to putting them in place and applying the load in the proper location to get the best results, right? Of course, in a load pin's case, you have to locate it so that the directional arrow, is in the direction of the loading. And, so all these kind of tips are in the different manuals or installation instructions for the product that you're purchasing. So if you can't locate it, feel free to contact an application engineer to help you. Tip number 3, calibrate the force sensor regularly, especially in safety situations. Very, very important. Recommended once a year, but it depends, right? If you're doing something that during the lift, something happened that was, load shifted and put an unusual shock on the load cell, and you're questioning whether something happened to that load cell or to that load shackle or load pin, we recommend that you get that in right away for an evaluation. And if it's a critical situation, you should really have a backup sensor nearby, because you don't want to shut down your operation because you didn't have a backup piece of equipment there. Next slide. Based on each use case, instrumentation can make all the difference. This is true, right? I mean, if we're talking about using a 1200 series or an 1100 series because the precision is important in your lifting application, then you need to have an instrument that matches up, something like a 9325. Of course, if you're doing wireless, you'll want to make sure you have all the proper instruments you need to, if you need a relay module to set alarms, you got to make sure you have that. If you need to record it, you need a WTS BS4 or BS3 USB base station. You need to make sure you have that instrumentation so you can log and graph it on your PC. So again, that's all about the planning process. Just make sure that you think of all those things before you do it, and maybe even do a walkthrough. That way you place your PO, you get all the equipment you need. We'll calibrate it here all together so it works the way it's supposed to, and you're just focused on making your installation into your application. And tip number 5, always do it with safety in mind. Keith brought up some really great points, and some of this stuff we just don't think about ahead of time. So again, part of the planning process, can my load shift? Have I taken everything into account? Did I, mark the load points in the structure I'm trying to move? Have I taken every step? Is it in a hazardous environment, so I need special equipment? Just keep all those things in mind, and then get the proper equipment that matches. It's, we have some customers that come to us and say, 3 times overload is fine for my application. We have other customers that come to us that say, we need 5 times overload. And so we address whatever the customer's need is. It's just a case of you being able to convey that to us. We can get you a product that'll match your need. Next slide.
All right, facts, frequently asked questions. So, how much capacity greater than the maximum load is ideal? Well, it depends. A lot of these, that'll be the answer. But certainly want to know what the maximum load is that wants to be lifted. We also have to consider what might happen if, say, a load shifts or something happens that isn't expected. And then you also have a safety factor. So it could be that whatever the maximum possible load is, including, say, overload or something going wrong, you have to have maybe a safety factor on top of that of up to 5 times for safety purposes, for example. So it's very much application specific, and many times you might need quite a bit more safety factor or capacity in the load cell than you might expect to allow for the required safety factors. Number 2, can vibration impact the output of the sensor? Absolutely. Vibration, imagine I have a display that's fast acting and the vibration is causing the load to change. That'll cause your display to roll around, might even be such that it's difficult to read. So how can you mitigate that? Filtering, for example, if you have relatively high sample rate, you might have a display that filters that out so it reads steadily. You also might be monitoring that with the data acquisition system that is actually reading the higher speed data so you can see these vibrations. If you have impacts or things that could affect the life or the safety factor of the sensor, you'd want to necessarily know what those are, not filter them out. But yeah, vibration can cause issues with reading a display, certainly. What are the key considerations when mounting a sensor used for lifting? Well, one is definitely the attachment points to the device being listed, and also the sensor and any things in line with the sensor, like clevises, rod-end bearings. Everything has to be rated for not only the load being lifted, but any safety factors that are required. Also, load cells and sensors have a load axis. It's important that fixturing and things allow the load to be aligned with the load axis. So you imagine if, say, a load cell is, say, hard mounted, and then you have a sling or something attached that's coming off at an angle, that won't work very well. It's creating a lot of bending loads into the load cell. It's not going to measure accurately. So again, you maybe want a rod end clevis on each end of it, for example, so that it can self-align. Obviously, then something like a load shackle or a tension link kind of has that feature built in, or it wants to self-align. Number 4, can you set alarms if the force sensor readings exceed a certain threshold? Absolutely. A lot of devices, instrumentation used in lifting have that feature as a standard feature where you can set thresholds, and if the load exceeds a certain threshold, you might get an alarm. If it exceeds another threshold, you might get a louder alarm or a shutdown trigger. So absolutely. What instrumentation is best for analyzing performance data during lifting process? Well, typically you want instrumentation that allows logging of the data, and you might want a relatively higher sample rate than if you're just visually displaying the load. And that's so you could say, look at it afterwards and see what happened. Again, if say something drops, you may not even see it happening on a display, but if you were monitoring the load in real time with a relatively fast data collection, you might see these spikes. And if you have a safety factor and the spike exceeds that, well, you need to take that part out of service, and it may be completely compromised if this load exceeded a certain level, and you wouldn't necessarily know it if you weren't analyzing that data, say in a high-speed instrument. What are the limitations of using wireless sensors and instrumentation for lifting? Certainly line of sight and distance. They can transmit up to 500 or 600 meters line of sight. If you don't have line of sight, it drops dramatically. You can potentially transmit, like say, from one building to another. It may or may not work. A site survey can tell you that. If it doesn't, there's things, remote antennas and repeaters and things can be added to a system. But definitely there's also a limitation of data rate. If you want like very high data speeds, you want a lot of load points, wireless may not be the answer. So definitely application specific. Number 7, if you embed a sensor into a lifting machine, how do you recommend calibrating it? Well, it depends, but in most cases, calibrating the entire system makes the most sense. It's the most accurate and takes into account all of the components in the system. Whereas if you just say calibrate a load cell by itself, you're not really sure how it interacts with the rest of the components in the system. So ideally, a lifting device, you'd lift something of a known weight, and that would tell you if it's operating correctly, and then you can actually use that known weight to adjust and calibrate the instrumentation. Are there limits for environmental conditions? Absolutely. Extreme cold, extreme heat, moisture, all of those things are extremely damaging to sensors and systems that aren't rated for them. So it's important. It's not just an afterthought. What is the environment? Is it in a steel mill? It's going to be lifting a vat of molten steel. Well, that's important to know. Is it outside? Is it going to get rained on? Is it on a ship deck? Is it submerged below the ocean? Or is it freshwater or saltwater? How deep is it going to be? All of those things can be handled, but you need to know it going in, right? You don't just take a standard load cell or load pin and put it in a shackle down in the ocean without rating it for that. What is the ideal accuracy rating of a sensor for lifting? It depends. A lot of lifting, it's maybe not as important for super precise accuracy. If you're weighing something or lift, it might be. Or if, say, you're handling something that's extremely critical that the lift, and say you're fitting pieces together, you don't want to press them together or allow the weight of the system to press the parts together with too much force, it might be extremely important to measure for accuracy. It really depends on the application. But for lifting and rigging, it's usually accuracy isn't the driving factor. It's more, monitoring and making sure things are being done safely. Why would you choose a load shackle over tension link for lifting application? Well, as Ken talked about, you've got like our low profile load cells. They have threaded holes. They don't necessarily lend themselves to lifting without adding extra items, shackles, clevises, whatnot. Something like a tension link has holes in the end. You can actually put shackles in those holes, or you can, put slings through the holes. So they're a little easier to implement into, say, existing lifting equipment. And then something like a shackle is maybe the easiest, right? Most lifting devices might have hooks or, loops or things that you intend to loop through something. Well, the shackle is an ideal thing to do that with. And if you have a shackle that measures load, it's quite easy to fit that into an existing system. Or systems already have shackles, you just replace the shackles with load monitoring shackles. And that's it for the facts.
That's a great question, questions and answers, Keith. We had one come in that said, when you replace a pin for a load pin, replace the pin with a load pin. Do you need to get that approved or notify the body of who's regulating the equipment?
Well, I would say in some cases, yes, in some cases, no. A lot of times we were working with, say, manufacturers, so training manufacturers, somebody, they're going to handle that themselves. It's an end user. It depends what regulations they're required to adhere to. But in very many cases, yes, the answer would be yes.
And our partner has the ability to do many different certifications on the pins. Of course, that comes with a price, but if it is a requirement, as long as it's conveyed to us, we can get that quoted and included in the price of the pin.
Yeah, that's right. Yeah, Ken brings up a good point. Things like Sharpie, rupture testing, and various things that are related to safety and lifting, those can be performed on the actual product and the certification provided with the product.
I've got another great question. The specifications of the tension link load cells show that its operating range is -4 to +158. Can the custom version go below -4 degrees Fahrenheit?
I would say yes. I know for sure in a shackle, it's been done. So, using the same manufacturing techniques and gauges and etc., it could be done, but for sure we could do something like that in a shackle because we've done it before They're moving around, towing around vehicles in Alaska, and sent us some pretty cool pictures, dragging them across the ice.
That sounds fantastic. If there's any other questions, be sure to use the chat feature. We'll certainly get those, as well as our application engineers are available to address your specific application needs. As detailed in this presentation, there's a lot of considerations that need to be made based on your environment, the type of use, the equipment, whether you're retrofitting or whether you're using it as a standalone. And it applies to all kinds of industries. You saw rigging of large craft that is going into a test environment or moving big loads or in a warehouse. So lots of great opportunities to utilize different types of sensors to get the best return on your investment. As we wait for any more questions, I just want to remind everybody, we are a trusted partner. We've been doing this for about 55 years now and counting. We have a lot of engineers here who, again, today you heard some of that expertise that design our products, build them, test them, and distribute them, and as well can work to get those systems completely calibrated to work together when you buy multiple devices for your application. One thing that's important is that we design our load cells for precision. Accuracy may not be the driving force, as Keith noted, in your application. However, you can count on our products to be built with precision measurement capabilities. We do customize our products, as noted, do a lot of customization, including putting alarms on tops of boxes to make sure nobody gets hurt in a lifting application or use case. We have a lot of specifications on our website for every single product. And if the specification questions you have, like we just talked about, exceed or are different than what we have listed, be sure to get in touch with us. We have a very talented team of custom engineers that can help define your exact requirements. And just to end this, if you have any needs, contact us. We're here to help. And we really appreciate you taking the time to join us today. I don't see any more questions coming in, but if you do have them, be sure to reach out. We have a very large network around the world that will work with you as well to define your exact specifications and use case requirements. And with that, I want to thank you for joining us today. Keith, Ken, always learned a lot from you, and I would just appreciate you taking the time to share all that great info. Thanks for joining us for Force Leaders. We'll see you next time.
Thanks, everybody.
Thanks, everybody.